we are asked to solve the given quadratic inequality. Looking at the inequality, let's first set the right side equal to 0 by subtracting 8 on both sides. The given inequality is equivalent to negative x squared plus 3x minus 8 greater than or equal to 0. The next step is to solve the related equation, which is the quadratic equation negative x squared plus 3x minus 8 equals 0. If we want to try to solve by factoring, we need the x squared term to be positive, so we can either multiply both sides by negative 1 or factor negative 1 from the left side. Let's factor negative 1 from the left side, which gives us negative 1 times the quantity positive x squared minus 3x plus 8 equals 0. And now let's see if the trinomial inside the parentheses factors. If it does factor, it will factor into two binomial factors. The first term is x squared, which is equal to x times x. The terms in the second positions would need to be the factors of positive 8 that add to negative 3, but there are no factors of positive 8 that add to negative 3, which means this does not factor, and therefore to solve the quadratic equation, we will need to use the quadratic formula shown here below. So let's go back up to this form of the equation, where a is equal to negative 1, b is equal to positive 3, and c is equal to negative 8. And now let's perform substitution into the quadratic formula. The quadratic formula gives us x equals, in the numerator, we have negative b, which is negative 3, plus or minus the square root of b squared is 3 squared, and then minus 4ac is minus 4 times negative 1 times negative 8, all divided by 2 times a, which is 2 times negative 1. And now let's simplify. We have negative 3 plus or minus the square root of 3 squared is 9. And then we have minus 4 times negative 1 times negative 8, which is minus 32, all divided by negative 2. 9 minus 32 is negative 23, giving us x equals negative 3 plus or minus the square root of negative 23, all divided by negative 2. Notice how the radicand is negative, and therefore the square root of negative 23 is imaginary. Remember, the square root of negative 1 is equal to I, and therefore this simplifies to the quantity negative 3 plus or minus I square root 23, or square root 23I, all divided by negative 2. So notice how here the solutions to the equation are complex, which means there are no real solutions for x that satisfy the equation or make the expression on the left equal to 0, which means all the real values for x make the expression on the left either greater than 0 or less than 0 or positive or negative. So normally we take the solutions to the related equation and plot them on the number line and then test the intervals, but in this case we can select any real number on the number line and see if it satisfies the inequality. If it satisfies the inequality, then all real numbers will satisfy the inequality. If the value does not satisfy the inequality, then we have no solution to the inequality. So for our test value, again, we can select any real number. Let's select the easiest real number to perform substitution with of x equals 0. And let's use this form of the inequality rather than the original. If we substitute 0 for x, we have the opposite of 0 squared plus 3 times 0 minus 8 greater than or equal to 0. Simplifying on the left, we just have negative 8. Negative 8 greater than or equal to 0 is false, and therefore all real numbers would be false, and therefore there is no solution to the quadratic inequality. So we state no solution. We can also denote no solution using the empty set or null set using this notation or set notation with no elements in the set. Before we go, let's also verify the solution graphically. Considering this form of the inequality, to check this graphically, we can graph the function f of x equals negative x squared plus 3x minus 8, and because we want to determine when this expression is greater than or equal to 0, we want to determine where the graph of the function is above the x-axis. Function values are positive above the x-axis, equal to 0 on the x-axis, and negative below the x-axis. Looking at the graph, notice all the function values are below the x-axis and therefore they're negative, and negative values are never greater than or equal to 0, which verifies we have no solution to the quadratic inequality. I hope you found this helpful.